Hello ladies and gentlemen, welcome to my video. Here we would like to solve integral 0 to 1 inverse tangent of 1 over x minus 1 dx. The question looks simple, but it requires some effort, including substitution and integration by part to solve it. First, define y equals to inverse tangent of 1 over x minus 1, and then t is 1 over x minus 1. Therefore, y equals to inverse tangent t, and dy over dt is 1 over t square plus 1. Meanwhile, dt over dx equals to negative 1 over x square, and we can write t equals to 1 minus x and then divide by x. Put this into dy dt. Therefore, dy over dt equals to numerator is x square, denominator is 1 minus x square, and then plus x square. From here, we obtain that differentiate of inverse tangent of 1 divided by x minus 1 equals to dy over dx, which is equals to numerator is negative 1 while denominator is 1 minus x, the whole thing power 2, and then plus x square. This result is needed during the integration by part later. From the original question Q, let's do integration by parts. First row is positive. We choose inverse tangent of 1 divided by x minus 1 for d, and we choose 1 for integral. Second row is negative, and the result for d has been derived before this, which is this one. Let's copy into the table. And then integral of 1, we have x. From the table, we get the q equals to the first term, which is x multiplies inverse tangent of 1 divided by x minus 1 for x equal to 0 and 1. The second term is plus integral 0 to 1 x divided by the whole 1 minus x power 2 plus x power 2 and then dx. For part 1, put in x equal to 0 and x equals to 1, we have 1 multiply inverse tangent of 0 minus 0. For part 2, we expand the denominator so that it becomes 2x squared minus 2x plus 1, while the rest are the same. Obviously, part number 1 equals to 0. Therefore, q equals to the part number 2. But we multiply 2 at the top and at the bottom. Therefore, become 2x divided by 4x squared minus 4x plus 2 dx. We purposely rewrite the 2 become 1 plus 1 so that we can complete the square. And then numerator change to 2x minus 1 square plus 1. Define u equals to 2x minus 1. We obtain du over dx, and then we get dx equals to du divided by 2. From u equals to 2x minus 1, we have 2x equals to u plus 1. When x equals to 1, u equals to 1 as well. When x equals to 0, u become negative 1. We have q equals to integral negative 1 to 1, u plus 1, divided by u squared plus 1, multiply du divided by 2. We factor the 1 over 2, take it to the front, and then we can split the integrand become 2 parts. Part number 1 is u divided by u squared plus 1, while part number 2 is 1 over u squared plus 1. Both parts are integratable, which is equals to 1 over 4 multiply natural log u squared plus 1, and then plus inverse tangent of u. For both, u equals to 1 and negative 1. Put in the value of u equals to 1 and negative 1 into the equation. Obviously, the natural log 2 will minus with the natural log 2, so becomes 0. While the second part becomes 1 over 2 multiply inverse tangent of 1 and then minus inverse tangent of negative 1. We know that inverse tangent 1 is pi over 4, while inverse tangent negative 1 is negative pi over 4. That brings us to the conclusion of this video. The final answer of this question is pi divided by 4. Thank you for watching this video until the end. I see you in my next video. Bye bye.